Hey guys, welcome back to MathsCube. Today I'll be solving the B and the C part of the final and the 8th question of Mechanics M1 International Advanced Level, which is of the Jan 2021. So without further ado, let's get started. For solving the B part, it asks us to find in terms of H the range of possible values of D, and that's of 7 marks, so a bit of working is required here. So what we can do is I've highlighted the parts, the stuff that we have to take in or consider as handy while solving this question. So the particle A is held at rest on the plane at a distance d meters from the pulley. Okay, we can see that, and the particle B hangs freely at rest, which means that u is 0 vertically below the pulley at a distance h meters above the ground, as shown in figure 3. The part of the string between A and the pulley is parallel of the line greatest slope of the plane. On hitting the ground, B immediately comes at rest, and they say that given that A comes to rest before reaching the pulley, we have to find the D values. Now to find the D values, first we can find H values, or in terms of H. So what we can do is we can use the formula F equal to ma, or the previous formula we were using for B. I have also written all the values here. For the T, the tension, that's 23.5 newtons, the A or the acceleration, which is 3.92 meter per second, and the R value or the normal contact force, which is 15.68 newton. So what I'll do is, I know that my U is 0, so I can find my V value by using Survet equations. So if you're wondering in this case which Survet equation to use, we basically know that our S, or the distance or displacement, is equal to h that we are finding. Our v we have to find, and our u is given as 0, and our acceleration is also been given. So what I can do is I can use this equation. There you go, v square is equal to u square plus 2as. Now what I'll do is I'll just plug in the values. There you go, v square is equal to 7.84h, as we know that u is 0, so you will eliminate from the equation. Now this was the equation used for the particle B. Now we will look at the main part, or the main particle, which we have to find the D value for in terms of H, which is the A particle. Now if we consider the A part, this A part, or the particle A that moves in that direction, and if you know, the coefficient of friction was between A and the plane is 1/4, or the quarter, which was in this direction. So there are a lot of forces to be considered here. So what we can do is we can either use the formula F equal to ma, or you can use the same formula, which was v square equal to u square plus 2as. So guys, these were the equations that were related to the particle A, which can be v square equal to 2as, or t minus 2g sine alpha minus a quarter r equal to 2a. Now the second equation I just said now, which was previously used in the A part, is the most prominent one, because we can either use 2a, which is equal to that all, and just plug it in here, and we can find the S value, which is in terms of H. So guys, one more thing here, we have to, if you use your common sense, we don't have to use our T value here, because we have to eliminate T, because we need to find the equation in terms of V and H only, that will give us the T value here, finding it in here. Now the reason to eliminate T is because either way, the method we used in A was simultaneous equation to find the value of A, and we eliminated T first, then we found out the T value, and this is the same case here. So what I'll do is I'll just eliminate T if we are using both equations, the particle A and B. Now what you can guys do is just take the value and plug it into calculator. 2g is 2 into 9.8, and sine alpha you can find from this triangle here. So sine is, so, or you can say opposite upon hypotenuse, so that's 3/5. So 2 into 9.8 into 3/5 will give us, and then using quarter of r, or r, you can see the value of r is 15.68. so 15.68 upon 4 will give us, there you go, minus 11.76 minus 3.92. do some basic maths and we'll find out that that's, there you go, 2a is equal to 15.68, or simply the r value here, and when we plug it in, use the positive value. There you go, v square is equal to 15.68s. Now just plug in the v square of b value here into this equation. There you go, Now to make the s subject, what I'll do is I'll divide everything on both sides by 15.68, and we find out that our s is equal to half of h. Now to make sure that the range of possible values of d are within the terms of h, what we can do is we can again use the formula or the Stewart equation, v square equal to u square minus 2as. There you go. This time what I did is just subtracted u from both sides to bring it to the other side, which is v square minus u square. And the reason I'm using minus 2as is to make the equation, you can say, positive. So now what you can see is, if you see this line here, there you go, on hitting the ground, or you can say the given, there you go, this one, given that a comes to rest before reaching the pulley. So here is a, and it comes to rest somewhere here before coming to rest, so which means that the v square is equal to 0, or the v equal to 0, and our u value is there. What you can do is you can use your u value as, or it can be 2g sine alpha, because that was a friction force we were considering first. There you go, 11.76. so 2g sine alpha is 11.76. just cancel these negative signs out, and we have 11.76 equal to 2as. Now guys, remember the s here. To find d here, what we can do is we can eliminate d by h. We already know that s is equal to h, and this will sort out the problems occurring here to find the d. Now we know that 2a, or a value, is 3.92. just plug it in and we can find that s is equal to 11.76 equal to 7.84 into d minus h. Now what I'll do is I'll divide everything on both sides by 7.84. Remember guys that we had s as equal to h, so we have to add the h there on the other side, and we have 1.5h equal to d minus h. To make d the subject, we can add h to both sides. So after dividing, we can have 1.5h equal to d minus h. We don't necessarily have or want h on both of the sides by adding them, so we can simply just remove them. So there you go, just remove this h. Or if you want to add, you can add. That doesn't mean, because h is equal to s. So our final question was to find the range of possible values of d. So what we'll do here is we'll just change the equal sign here, and we'll go about and say that 1.5h is less than, there you go, that's less than d. And if you can see on the diagram here, sorry, it's been past here, there you go, if you can see the diagram, the d is a lot greater than h in size, and it makes sense if you look at the answer here. Moving on to the C part, which is the last part, and it is state one physical factor other than air resistance that could be taken into account to make the model described above more realistic. This is a very easy question. If you can memorize the questions like these, you can get 1 marks easily. There are a lot of points that have been stated to answer these kind of questions. You can simply say that the string is inextensible. Now the reason I wrote this answer is because we can say the string is inextensible because we have taken the acceleration, you can say, on the both sides of the particle as same, so that this acceleration is equal to this acceleration at p. And you can see why, because the acceleration value was remain constant here, so the acceleration value is same on the both sides. Thank you for watching guys. Stay tuned for more videos from this series.